So with this question, and remember all your bell work questions are practice ACT questions. So it's not super important that you get all these 100% right, but the important thing is that you're trying them and that when we go through the answer, it's hopefully helpful for you to kind of catch where you made your mistakes. So the answer, the first thing that we've got going on is that it gives us a function. So we know that f equals c times d cubed. So I can plug, well, let me just bring this down. F equals c times d to the third power, or cubed, that's another way of saying it. So 450 can be plugged in right here for F. And then C is what we don't know. In fact, if I read the question, I can see that's what they're asking me to solve for. D is already given as 10, so that's going to be 10 cubed. Now, this is something you can use your calculator for. Remember, 10 cubed, 10 to the third power is just 10 times 10 times 10. You might be able to do that in your head, but 10 times 10 times 10, if you do that, you get 1,000. So 450 equals 1,000 times C. And of course, now what we need to do is we need to divide by 1,000. And again, you can theoretically do this part in your head on the left, but you know, if you have a calculator there, you want to just plug those numbers in. There's nothing wrong with that. And 450 divided by 1,000 is just 0.450. So your answer is actually A. Now, a lot of you answered D or J. A lot of you answered this, which is not correct, but it's pretty, I can tell what you did, where maybe you didn't look at it closely enough and you just assumed that you could take F and divide it by D, and maybe you didn't catch that it was cubed. And if that cubed hadn't been there, that would have been the right answer. But if you just did 450 divided by 10, you'd get 45. But that's not correct because it's actually 450 divided by 1,000. Okay, enough about that question. Hopefully you caught any mistakes that you made. All right, so for today, we are going to do, you can see proportions review. So this part of it shouldn't be anything new. And multiplying radicals, this will possibly be new. Hopefully you've actually experienced this before. You've learned a little bit about it before. But anyways, we're going to do that. And then I wanted to start by talking a little bit about Study Island. If you could give me a thumbs up real quick if you have used Study Island already and you're familiar with it. I got one thumbs up. Okay, a couple. Yeah, I'm seeing some thumbs up. So some of you have familiarity with this, and maybe you have used it, but when I say Study Island, it doesn't ring a bell. So we're going to go through this more tomorrow. I'm just going to be giving you a heads up for today that we're going to be doing some benchmark tests through Study Island. And as far as that goes, these benchmark tests are just being used to check your understanding. They're relatively short. It's going to go back to kind of the first stuff we talked about and the unknown angles. It's not actually going to include the midpoint formula and stuff like that, what we just had on our test. So they're relatively short, and the grade that you get is not being used to count against you. I will make it a participation grade just for doing the benchmark, but the grade itself, whatever you earn, doesn't count against you. So just be aware of that. And if you see a question on the benchmark that is unfamiliar to you, it's something that seems like we didn't cover in class, just give it your best shot and come up with what you think is the best answer. And you'll surprise yourself, a lot of you, that, you know, just what you think is the correct way of approaching the problem is a lot of times exactly right. So go ahead, even if it's a unique problem or just an unknown problem, go ahead, give it your best shot. That's about it. I will give you more information tomorrow, and that's what you can count on doing. And there'll be 2 of them. I think maybe a total of 10 questions between the 2. I think each of them have maybe 4 or 5. So just want you to be aware. Now I immediately here jump over to our homework because I'm actually going to go over to Delta Math today to do our lesson. But just to let you know, you do have this assignment called Multiplying Radicals and Solving Proportions, which is on Delta Math. So as soon as we log off, I encourage you guys to immediately start work on that. This is review and a little bit of new stuff. So, and the new stuff might not even be new, depending. I don't know if you'll remember this stuff from the past. So let me get out of this and move over to Delta Math. And I'm going to, I think I'll start with the potentially what is easier. Now, whatever's easier for you, you can determine that. But this is review right here. You're solving proportions. And we've actually already looked at this in our bell work in the past. So this is, we've already touched on it to some degree, but today we're really going to focus on practicing with it. And what we have going on is a proportion. A proportion is when you take two ratios, like 7/4 and 21/x, and you set them equal to each other. And when we say we're going to solve proportions, that means we're going to solve for, as you can see right here, this missing value. We want to know what that is. Now I'm going to run through this the longer way. It's only slightly longer. And then we're going to refer back to a shortcut that you've probably learned in the past. So if I've got 7/4 equals 21/x, then what I want to do is I want to get rid of the denominators. All right. And the only way I can get rid of the denominators is by multiplying by those numbers. And when I say that, what I mean is on the left side, I want to multiply by 4, which is really 4/1. And when I do that, these cancel out on the left. So I just get 7 by itself equals 21 times 4. You can use your calculator on that. But 21 times 4 is going to be 84. And now that's still over x. Okay. Now I still don't want to have that x on the bottom. So what I'm going to do is I'm going to multiply by x on both sides. So this is technically over 1, but we don't have to show the over 1 on the left side. So at this point, these x's cancel out, and x times 7, so I have 7x equals 84. And now it's a one-step equation. So I'm going to go ahead and divide by 7. And I get 84 divided by 7. Again, you can use your calculator. You don't need to be able to do this stuff in your head. 84 divided by 7 is 12. All right, so that's kind of the ever so slightly longer way of doing it. It doesn't make it a long problem. But of course, the shortcut that you're probably already familiar with and that we will use is rather than worrying about getting rid of our denominators, we're just going to use what we call cross products, which if you think about it, this just takes those first two steps where I multiplied by 4 on both sides. So that first step, and the second step where I multiplied by x on both sides, I'm really just taking both of those steps and combining it into one. All right, so I'm going to multiply 7 times x. So I have this diagonal right here. When I multiply those together, it's going to be 7x. When I multiply these two together, 21 and 4, it's going to be 21 times 4. And we already saw that's 84. So now is where I can just divide by 7, and x equals 12. All right, so we'll just do cross products from here. And there you go. I'm going to clear my work so you can see, even if you don't know how to do this and you go and you do a practice one, you just plug in a random answer. It will run through the process. So one thing it doesn't do very 100% is it won't give you exactly the steps for the cross products. So you need to understand that when it says right here to do cross multiplying, which is the same as cross products, that's where they're taking this right here and this right here and multiplying them. But if you understand that, then you can see how they came up with this equation. All right, so let's try another one of these. We'll just do a couple more. There we go. When it's a problem like this, you'll see that there's a negative, and maybe the first thing to do is to assign that negative to just one of the two numbers. And what I mean is, I'm going to write this as -2 over +7. And this is, I tend to put, if there's a negative fraction, I tend to make the numerator negative. All right. So now I can do my cross products. I'm just going to multiply those two numbers and then the other opposites right here. So -2 times x will be that first diagonal, and then 12 times 7, well, this is funny, we've already done that one. 12 times 7, well, we did it a slightly different way, so I'll just write it out. 12 times 7 right here. So -2x, this is going to be 84. Again, use your calculator. So, and if I'm going too fast, if this isn't making sense, we can go through, you can hang out, we can go through more examples. But let me just go ahead and finish this. I'm going to divide by -2. And when I do that, x equals, well, 84 divided by 2 is 42. But because it's a positive divided by a negative, it's going to be a -42. So let me try that. -42. And there we go. That was it. All right, let me just do one more. And like I said a minute ago, if you want to get some more practice with this, you still don't understand it, hang out after class and we'll just do as many as it takes. -13 over 2 equals x over 4. So let me go ahead and multiply right here. And the cross products, so if I start with this one right here, that one's 2 times x. If I do this one next, it's going to be -13 times 4. So that's going to be 2x still over here, but -13 times 4, plug that in your calculator or just do it by hand, whatever you prefer. You should get -52. And you can confirm that real quick. If you've got, you should have your calculator handy. You can confirm that's true. So now I just want to divide by 2. And x equals, when those cancel out, -52 divided by 2, well, 52 divided by 2 is 26. But again, if I've got a negative divided by a positive, that's going to make it a negative product, or a negative quotient right there. So let me plug in -26. And there it is. So if you are going through this tonight and you make a mistake, keep in mind, Delta Math will show you the correct process. So it will self-correct. And then when you do the next one, you should have a better idea of where your mistake was and how you can correct it. All right, I'm going to call that good for now. But if you, I mean, I've said it already a few times, but if you need some more help, we can go through some more problems. So the next one we're going to do, this is going to be possibly new for everyone here. And we're going to be looking at multiplying radicals. All right. And this one, it'll be, if you have been practicing with simplifying your radicals, this is only going to be a short step. It's just going to be a little bit extra. So notice it's asking what's the product of the square root of 14 and 10 times the square root of 12. So I've got square root of 14 times 10 times the square root of 12. This is really what it's asking me to do. Some of the problems will look like this, where it gives you a word or a sentence, a question, and you have to figure out that you're multiplying. Sometimes it just gives you the formula. It gives you the calculation like this, and we'll see that in a second. So when you are multiplying radicals and whole numbers and things like that, we can only multiply like terms. So I keep wanting to say negative. The square root of 14 can multiply by the square root of 12, but it can't multiply by the 10, not directly. So when I say that these can multiply together, essentially what I'm going to say is that this 10 is just going to hang out. And now I can do, under the radical, I can say this is going to be 14 times 12. And if I do 14 times 12, that is going to be 192. I don't know. I'll actually plug it in. 168. See, good thing I'm not counting on my mental math. So there it is, 168. Now this is not as simple as I can make it. So if I just plug this answer in, that's not going to be sufficient. So remember, when it comes to simplifying radicals, we want to find the biggest perfect square factor that can fit into this number. So maybe the easiest thing to do, 4, 9, 16, 25. These are my perfect squares, 36, 49, 64. Let me just start with that. So if I want to figure out which of these perfect squares, this is 2 squared, 3 squared, 4 squared, and so on. So if I want to figure out which perfect square is the biggest one that can factor evenly into 168, I'm just going to start with 4. So I'm going to do 168 divided by 4, and you get 42. So that's good, but I think I can do better. I think there's going to be another number that can factor into this. So let me try 9. So I'm going to divide this by 9. So this one works, but I'm going to see if there's another one that can work also. So if I divide 168 by 9, I get a really weird decimal. So that one doesn't work. I mean, it's 18.6 repeating. So I don't want that. All right, so let me erase that. So this does not work. Let me try 16. So I'm going to do 168 divided by 16. Again, I get a decimal if I try that. I get 10.5. So that one doesn't work. Now, maybe 4 is the biggest one we can do. We'll find out. Let me skip 25. I mean, if I try 25, 168 divided by 25, we can probably tell that's not going to be a whole number. It's some weird decimal. So I'll put an X by that one. Let me try 36. 168 divided by 36. I'm feeling good about this one, but no. 36 is 4.6 repeating. So again, that one doesn't work. Anyways, we can keep going until we find what is the absolute biggest perfect square factor we have. So I'll try 168 divided by 49. Nope, a weird decimal. And 168 divided by 64. And that's a weird decimal too. So strangely enough, it actually is 4 is the biggest perfect square factor that works. So when we did that, that was 4 times, or let me write this the right way, I'm sorry. I have this 10, and then it's gonna be times the square root of 4 times the square root of 42. And the square root of 4 is 2, so 10 times 2 times the square root of 42. So this, I just took the square root of 4, and now I can multiply that out. It's gonna be 20 times the square root of 42. And this is one you might think that there's another perfect square factor there, but I guess that's our most simple answer that we have, our simplest one. So I'm going to put in 20 times the square root of 42. And that was it. So if you get to a point where you're like, I think that's as simple as it can get, just test it out. So let me go ahead and clear this. So you can see the steps right here. Again, if you're trying this and you don't fully get it, you can figure it out. So the square root of 14 times the square root of 12 gives us the 168. And we can see the biggest perfect square factor was 4. And there we go. I'm going to run through a few more of these, 2 more to be precise. And I'm going to pull up a different question type real quick. So notice that right here, this is division. We're not doing that today. We're going to do that at a different time. So your questions, when you look at them tonight, won't have that. But you might get a question that looks like this. It just gives you straight up, multiply that out and simplify it. All right, so square root of 6 times the square root of 12. I can multiply those together, and that's going to be the square root of 72. And I've got my perfect square factors. There's 4, 9, 16, 25, and 36, and then 49. I think we're good at that point. These are always the same. Remember, we talked about this at the beginning of the year. It keeps coming up every week when I give you practice on this. These are your perfect squares. There's a multiplication table on the Canvas page if you need to have a reference for those. All right, so that's, again, 2 squared, 3 squared, 4 squared, 5 squared, and so on. So let's figure out what's the biggest one that can factor into this. And maybe you're looking at it, you already know, but maybe we could try 4. So 72 divided by 4, and when I'm saying 72, it's what's under the radical. So 72 divided by 4, well, that works, and it's 18. So 4 works. Let me try 72 divided by 9. And that's 8, so 9 works also. Let me try 72 divided by 16. It does not work. I get a weird decimal. And I specifically got, when I tried that one, I got 72 divided by 16 is 4.5. So that's why I'm not counting that one. All right, the next one, 25. We could probably tell 25 isn't going to work. That'll be a weird decimal. So let me try 36. 72 divided by 36. And that one works. So I'm feeling pretty confident. If all that's left over is 2, then what I can say now is that 72 is the same as the square root of 36 times the square root of 2. And the biggest number that I can find, which in this case was 36, is the number I want to use. So the square root of 36, we know that. The square root of 36 is just 6. And that's as simple as my answer can get. And there we go. We can see the full process. I'm going to clear my work. We can look at the screen. So figure out where your mistakes are if you don't get the right answer. I'm going to do one more. And like I keep saying, if you're still not understanding exactly what we're doing here, then stick around. I want to, let's go ahead and do this one. So notice here that it's going to be the product of 6 times 2 square root of 72. So just like before, I said, if you have radicals, you can multiply your radicals together. But here I just have a couple of whole numbers and then this radical over by itself. So what I want to do is actually want to multiply these two together, and I'll just leave that square root of 72. So 6 times 2 is 12. And again, that square root of 72 is still there. And now what I need to do is figure out the best way of simplifying this. Now, luckily, that was the exact same problem we just had. So we know that this is the same as 12 times the square root of 36 times the square root of 2. All right, we got lucky that they gave us the same radical 2 times in a row. Okay. So now the square root of 36 is 6, so it's going to be 12 times 6, because notice this got converted into a whole number, times the square root of 2, but everything else just stayed the same. So the square root of 2 just came down, this 12 came down. This actually got converted. So now 12 times 6, if you multiply that out, is 72. All right, so hopefully you guys were following along with those 3 examples. I'm going to put this number in, 72 times the square root of 2. Make sure that's right, and it is. So if you have questions, if you need to go through 10 more of these things, 10 more proportions, whatever you need to see for today, feel free to stick around. If you feel like you understood it and you're ready, I want you guys to take care of doing that homework right away. So at this point, stick around if you have questions, but otherwise have yourself a wonderful day, and I will see you tomorrow.